All right, well, welcome everybody to the December Geo community call. Our agenda today is very simple. Elias is going to give an update on what he's been doing, and then I will give one. They're both probably going to be kind of short, and then we will have an extended chance to do Q&A and for people to do little show and tell sessions on whatever they've been doing lately. And when we either hit an hour past or we run out of content, we'll call it. So yeah, thanks for coming. I'm going to hand things to Elias to give his updates.
So thank you very much, Chris. Can everyone hear me? Just Chris, can you? Yes, of course. So first of all, I'd like to thank you, Chris, for hosting this event. It's really helpful to have this going again. And also, Chris, you've done some excellent newsletters, which I'm also very happy that you managed to collect and collate all of the new developments in the Geo community. So for today, I'm going to present my work on the new backend, the new renderer backend for Geo. I'll see if I can find. So you should be seeing my screen right about now. So the Geo compute renderer. Speak up if you can't see my screen. I'm just going to assume that you can. So the Geo
yeah, we can see.
Yes, of course. Thank you. So it's a new renderer for the vector graphics. Sort of the vector graphics library or operations that Geo consists of. So everything that you draw, the widgets, text, custom drawings, graphs, and so on, are done with vector drawing instructions, such as this is the path. Please fill the outline of this path with this color or this image, and so on. And up until now, it's been done with the original renderer that I wrote and released as part of the Geo's public release last year. And I'm currently working on replacing this with the GPU project that Raph has done. He's from the Rust community, an excellent, all-around cool guy. And he's trying to do sort of the same thing as we're doing in the Go community. He's trying to make GUI development and 2D graphics much more pleasant and accessible, at least for the Rust language. And Raph agreed to share his work, at least in the form of the GPU programs, the compute shaders, so to speak. And this is the ones that you see in his PyGPU repository. And all the files that ends up with comp are actually programs that you run on the GPU. And he's agreed to share them using the same license as Geo itself, which is the MIT and unlicensed. So that's very generous of him. And I've been working on improving that because it's not production ready yet. So I've been working mostly to fix the bugs in it and make it more appropriate and add all the features that a real Geo GUI library, such as his own, but also GUI, the work that the operations that we need are supported. And the difference between this one, the new way of render, because Geo already uses the GPU to render vector graphics. The difference is that it uses general purpose programming. It's called compute shaders, because you can if you see one of the programs, let's just take one of these. They mostly look like a program, like perhaps a variant of C that you would run on your CPU, and that's also almost the truth. You write it in a variant of C called GLSL. And you specify the inputs to it through these declarations here, and also the outputs so inputs and outputs are declared as a set of buffer bindings that you then provide to this program, and you can just dispatch it, which means that you run this main across all the available cores on your GPUs, on your GPU. So the problem with replacing something that already works, in the case of Geo, we already have a renderer that actually does work, and it runs on mobiles and so on. So the question is, why do go through all this trouble of replacing it? And the most important feature that Geo is lacking today is a way to run it on the CPU. Because if you can't fall back to drawing on the CPU, you can have devices that does not run Geo, and that's generally a showstopper for any GUI library. That if you can ask, does it run everywhere, and not have the answer, yes, it runs almost everywhere you could imagine, but have requirements such as you've got to have a GPU that actually works, and it doesn't have to be recent, but it does have to work, and the drivers has to work, and so on. And that's actually a showstopper. Concretely on my work with the Tailscale Android app, it's even open source on GitHub, I ran into the problem of this app not running on two low-spec phones. It was the Samsung J2 and the Moto C, because they simply did not have the required GPU extension supported to run Geo. So the Tailscale app just didn't run. So the idea of replacing it is that first of all, to have a way to fall back on the CPU, but also to gain all the advantages of a general purpose pipeline, because the 3D pipeline that you normally write even 2D graphics for is actually not a good fit for vector graphics. The requirements are different. You need higher precision at the edges for anti-aliasing and so on, which means that the current renderer that we have in Geo is actually not that performant. It's not using the GPU as well as it could, and is also complex to program, because you have to shoehorn all these 2D graphics descriptions into triangles and fragments that you use in the 3D world. So Pipe GPU, Raph's Pipe GPU, is both fast, it's simple to implement because it's just a general purpose programming model, and because it's such a general purpose model, it's simple enough to run the CPU, and that's what if we can find him. I don't think he's on the call, but that's what Victor Okerman has been working on a few months ago, which is a way to translate these programs here that are designed and meant for running on the GPU, compile them and make them run on the CPU, and that actually opens up a path for Geo to run everywhere. It can run, if it has this new renderer, it can run very efficiently on GPUs that support it. But you can also have a way to run on the CPU as a fallback. And as an added bonus, it's, as I mentioned, it's fast, and it's much easier to add these more advanced 2D vector primitives such as strokes and gradients and drop shadows and so on. We already have strokes in Geo, but they are currently implemented as taking these strokes and converting them to filled paths, which is both, it's not as efficient and may have issues with very small or very difficult to render strokes. So what's the catch? Well, I've been working on it for some while, at least a few months, because it's not yet production ready. It's mostly a research prototype, but it does work. It just had a few edges of issues that had to be fixed, and it also had a few features that needed to be implemented before it could actually be used and replace the other renderer that we have. And the most perhaps the hardest catch is that it doesn't work on browsers yet, because we don't have WebGPU, which is an upcoming standard for general purpose programming on GPU programming on the browser. And the catch, of course, is that even though there's a path to doing CPU rendering with this new renderer, it's still much slower than the GPU. So there's some work. There's yet some work to be done to have this fallback be as performant as you would expect. So you don't have the answer to, does it run everywhere? Yes, of course. But if you don't have a GPU, it will be very, very laggy and annoying to use. So yes, so the roadmap is that I have a working implementation that can render vector graphics, which is nice. It doesn't work on the Mac yet, so you're going to have to see it running on my phone. If you can see it, just see the Hello World Tiger, SVG Tiger, rotating here on the phone. So it works on Linux, it works on Android, and I expect to port it to Windows and Mac OS, the Apple operating systems. And I hope that with some testing and some time, it will be default on supported GPU. So if you have a newer GPU, you will have faster graphics and hopefully better supported and less issues. And the end goal, of course, is to implement this performant enough CPU version and then delete the old renderer. Because until we delete the old renderer, we can't enjoy all the advantages of the new renderer, because you always have to sort of implement whatever you implement the new renderer, you have to port that to the old one, so you don't have features that are missing on the old renderer on the old machines. So that's about it, I think. So anyone has any questions?
You can either ask questions out loud or in the chat, whatever works.
So Elias, you said, if I understand, you actually expect this to be faster, more performant long term?
Mm-hmm.
And is it now at this point, even on at least where it runs?
I haven't implemented one of the missing features. One of the things I haven't implemented is the conversion from GU operations to the operations format that this new renderer expects. So I haven't actually seen GU content rendering, but I do have a very interesting. Let's see if I can find. Raph did comparisons of the performance between some of the existing 2D renderers. Let's see if I can find it. It's here.
You did unshare your screen, so if you want to.
Yeah, I know. I'm just going to link people to the. So this is his blog post actually announcing his completion of the prototype renderer. And as you can see from, if you scroll a bit down on the blog post, the rendering times are so small that you can't actually see his timings, at least not on the first on his first graph, where he compares his own renderer with Pathfinder, which is the render that the current GU render is inspired by, and then the Cairo render, which is, I suppose, it's the default renderer on Linux for Linux GUI stuff. And then he goes in the next. He has two graphs. He actually zooms in to be able to see the timings for his renderer. So even Pathfinder, which is faster than our renderer, because Pathfinder implements all sorts of optimizations that I never did or got around to doing. So even compared to that, he's perhaps 10 times faster than that.
Cool. So he's like 600 times faster than Cairo, which we use. Is that what you're saying?
We're using, our best case is Pathfinder.
Oh, I see. Okay.
But I expect that we're slower than Pathfinder because it's inspired by the GU renderer is inspired by the Pathfinder, but hasn't followed its development. So any optimization since perhaps a year or two ago is not included in the geo renderer. So I would expect us to be maybe twice as slow as the red bar in his illustrations.
Anthony asked about API changes. Do we expect the user API to change?
No.
And Alessandra asked about whether this is a port of the Rust library to Go, or is it using the Rust library through CGO? And in that case, does it mean compiling a Geo program will require rustc?
Well, but that's one of the excellent things about this way of programming the GPU. It's actually very easy to program it. I'll just see if I can find the link to the current driver for it. So, see if I can find it here. So this is a link to the Go file that drives the sorts of specifies and uploads the data required for the GPU programs to process that data and display it on the screen. So what I'm doing is that I'm copying his compute programs, his GPU programs, which is in the format of these .comp. I showed it in the presentation, but this is one of them. So I take these and copy them verbatim. I try to match upstream so that any fixes that I do also lands in his work, is in his repository. And then I use a Go-based driver to specify the data, upload the programs and data, and then make sure that the image is drawn to the screen and so on. So it's actually much easier to drive these programs. It's not quite as easy as, say, command exec, as you would expect a sub process in a Go program, but it's similar. You specify these programs, you specify their input, and then you say run it. So there will be no Rust included, and you won't be requiring rustc.
Any other questions for Elias about this right now?
When do you think you'll be done?
I expect to be done this month. There's one issue left, which I'm working on as we speak. Not as we speak, but almost, which is that its memory support, its memory management is not dynamic enough. Right now, I just allocate several dozens of megabytes and then hope that that's enough to render the scene that you present to it. And I hope to very soon be able to make that memory requirements proportional to the scene complexity. So the complexity of what you're going to draw on the screen. And when that is done, I'm going to do what the actual conversion from GPU operations to PyGPU operations. So you can just see anything that you draw in GPU, see it running through this pipeline.
So at that point in time, we'll be able to run it on Linux and Android, right?
Yes.
Okay.
And that's where I'm either depending on the priorities, because I've spent quite a lot of time with this, and I hope to get back to other GPU issues as well. But depending on priorities, I may go further and also do the Windows Direct 3D port and the Metal port, because that's more or less just conversion of programs from one language to another. There shouldn't be that much work in terms of implementing new stuff and so on. So I hope to also be able to do that, but I don't know whether that would be top of my priority. And I also hope, of course, to introduce some kind of environment variable so that you can. So in the beginning, you will have this renderer activated if there's no other way to run GPU programs. So the concrete problems are the two phones, Samsung J2 and similar, and Moto C, which do not support the old renderer, but actually do support the new one, because the old renderer needs some extensions that are not available on some phones. So that's where the GPU, the new compute renderer will be activated, because there's no other way to run GPU on that those kind of devices. But it will not be default elsewhere. So I hope to introduce some kind of environment variable that you can enable, and then test that that your program works and your app works on the phones and so on. And after some time, I will switch it to be the default as long as your GPU can support it. And that's the first step towards replacing the old one.
Lucas asked if this means WebGL support will be dropped.
No, the old renderer will stay at least until we have a CPU fallback for the new renderer. So until we have, so Victor worked on compiling these GPU programs to Intel assembly and ARM assembly and so on, so that it can run on CPUs. But it doesn't mean that it is performant enough. If you just take these programs, compile it for the CPU, and run them, you will find that any non-trivial GPU program will be too slow to run, too slow to use interactively. So there will be the work to convert it to CPU, and there will also be some work to cache and otherwise optimize the CPU version of this renderer before it can be used as a realistic fallback. And at that point, I hope and expect that WebGPU will be supported on the browsers, in which case WebGL may or may not be dropped.
So it seems weird that running on the CPU on a laptop would be too slow, but running on the CPU on a phone would be fine. Is that what you're saying?
No, that's not what I'm saying. I'm saying that running on the CPU is slow. It is much easier. It's possible to do that much easier with the new renderer than the old one, which is it's almost impossible to translate. But it will be slow, period. Which means that translating to run on a CPU is not enough to make it as a viable fallback. You also need to do something where we cache. Right now, GPU just renders everything from the beginning at every frame. So we need something where the GPU backend can recognize, oh, this part of the UI is unchanged from the last frame, and then reuse the render stuff from that frame in this one.
I think, Larry, maybe the missing piece there is that this new backend doesn't require the same GPU extensions the old one did, and that's what enables it to run on new devices, or on those two low-end phones.
Yeah, there are at least those two low-end phones that supports a newer version of OpenGL, but which is enough for the new renderer, but does not support the extensions of the old version of OpenGL to run the old renderer, which is kind of that was unexpected for me. But that's the bonus of implementing this stuff, that you actually cover more devices, which is the primary reason is the CPU fallback. But for me, the bonus is that you actually cover more devices than you otherwise would with the old renderer.
Cool. Thanks.
All right. Well, thanks, Elias, for that. That's really exciting stuff, and I'm anxious to try once the actual GeoOp translation is supported. So I was going to briefly give a whirlwind tour of what's up in GeoExtras. So as many of you probably know, GeoExtras is a suite of things related to Geo that are either they don't belong in core, or maybe they're not mature enough to go in Geo core yet. And currently there are 7 libraries in GeoExtras. So I thought I would give you a quick overview of what is there right now, and give you a chance to ask some questions about it. So first up, Scroll. This was a collaboration between myself and Jack Mordaunt, and it just gives you a scroll bar. That scrollbar does support dragging, and it supports clicking at a specific place and jumping to that target. That's what that is. Outlay is a collection of extra layouts, things that you would expect to find in Gio's layout package. So I've shown this before, so I'm sorry if it's really old hat, but this is a radial layout that I've been working on, and it supports animated transitions between states. So you can play with a lot of its parameters in this demo program. But you can also see the biggest gotcha with it right now is it doesn't correctly return its dimensions. So Gio's unaware that it is overlapping these sliders. That's something I'm going to get to soon. Pierre Curto recently contributed support for grid-based layouts. So this is a vertical wrapping grid where these items will overflow by column, and then we can look at the same thing by row. This is a grid with a fixed height, but an arbitrary width. So if we add another 9, they'll overflow to the side. And this is kind of the same thing, but with a fixed width. So these will overflow downward. Neotify is a library for cross-platform desktop notifications. Currently, it supports Linux, BSD, Android, macOS, provided that your executable is signed properly, and iOS kinda, and I can elaborate more on that. But the demo just lets you push this button and you get this notification. And if there was an error, I probably shouldn't have pushed it that many times. If there was an error sending the notification, it'll populate in the UI here. Materials is a collection of material design components. So you've got like your standard app bar with overflow menu, and it can be docked to the bottom, and you can change the icons, and it has a contextual menu, which apparently I missed when I updated it for palette support. Okay, well, I'll be fixing that after this call. And there's a navigation drawer, which can instead be docked to the side of the UI. Jack Mordaunt, again, contributed an excellent implementation of text fields with these really nice, subtle, animated transitions where you've got your hint text, and when you click on it, it shrinks into the top. It feels really good. I don't know how the frame rate is, so maybe it's not easy to see. You can also have prefix and suffixes to the edited text. It supports displaying validation information. It has a built-in maximum character count. I guess the fastest way for me to hit it is probably to hold a key down. So there we go. And it supports aligning the text content to the start, middle, or end. So yeah, that's materials. Haptic, the example is impossible to convey through this medium because it's only a thing on mobile devices. But this has Android and iOS support for sending basic haptic feedback. So on those devices, when you click this button, the phone will buzz. My desktop does nothing. Events is not a GUI thing per se. Events is a collection of utilities for working with Gio's event queues. In particular, the SPY type, which is an idea that Elias had, allows you to wrap a normal event queue in a fake one that will grab a copy of every event that flows through it so that you can introspect them and possibly add behaviors. So originally, before Lucas added copy and paste support to the editor, I was using a SPY. I would wrap the graphics context for an editor in a SPY, and then I would render my editor. And then the SPY would give me a copy of all the key events that the editor had processed that frame. And I could look at them and see, did someone press Control V to implement paste? And it has some other applications too. And then there's a combine function that lets you take a context with its existing event queue and then inject another kind of literal syntax event queue if you want to add some synthetic events. Oops. And then color picker, this hasn't changed much, but it exists. So I have a widget for choosing a color, and you can also edit it directly. That is not a very dramatic change. Let's try making that a 0. But yeah, it also has a multiplexer for choosing one from some number of colors. All of these were just 10 hours ago updated to be compatible with the latest API. They are all licensed the same way that GeoCore is, so you should be able to combine them without any trouble. They have their own ticket tracker so that Cores doesn't get choked with bug reports for this. Currently, it doesn't have a dedicated mailing list. It just uses my public inbox, which is where a number of other projects go as well. And one final note, all of these repositories, their default branch is named main, not master. A couple of them, that changed yesterday, but they are now all set up that way. So yeah, that is GeoExtras in a nutshell. Any questions on that?
How difficult is it to integrate the scrollbar into a list widget?
It's not very difficult. I can actually show you the code because it's not very much. So, gotta find it. There's kind of a two-part to the integration. The first part is when you're doing your layout pass, you have to ask the scroll bar, were you moved during the last frame? And use the results of that to move the position of the list so that the controls where you drag the scroll bar or click in the scroll bar tray work. So that's what we're doing here. And then separately, we compute how many list items we think are visible. And you can use whatever heuristic makes sense for your particular use case to control what your view of the progress through the thing you're scrolling through is. So in a list case, it's kind of simple. You're counting elements, but since this isn't tied to use with lists, it can be used anywhere. You're free to define this. And you're also free to define, we want the scroll bar to scale its length with respect to the length of the scrolling region. And so you supply kind of what fraction of the visible region is visible right now. So the scroll bar doesn't, it accepts those values from you and reflects them. And you're currently responsible for providing that intelligence. I could see adding some helpers for like doing it with lists, but it's still not very much code to do it yourself. It's just this to compute it, and a lot of that's comments.
Gotcha. Cool.
Can the scroll bar go to course? The list automatically does it. Probably. Yeah. I haven't tried to modify list so that this is a native thing. So that might take some thought, but yeah, there's no fundamental obstacle there.
One thing about scroll bars and lists is that normally list items tend to be constant height, but they're not required to be. So you can have one thing that's 10 pixels and another thing that's 1,000, and that can screw things up unless you want to like know that in advance. So
the way that we're kind of currently thinking about that, and I guess we is Jack and I when we designed this, because lists are not homogeneous, and our core use case was actually the message history in Arbor in Sprig. Your messages are all different lengths. We figured that you can use some heuristics. In our case, we actually have a counter for the maximum number of things that have ever been visible at the same time. And that's what we assume is visible. So it's not perfectly precise, but it allows us to have like a decent heuristic without having to render every list item every frame to figure out the actual percentage that is visible. And of course, because the visibility percentage is like up to you as the integrator in its current form anyway, if you have a different heuristic you want to use, you can just plug it in. But yeah, there's no way to track with total precision what the visible percentage is without rendering all of the content in the list at least once. And I've thought about making like an alternate list type that does some kind of opportunistic off-screen rendering, not like all in one frame, but maybe as frames pass, it renders elements that are distant from the current screen just to figure out what their dimensions are. And that way it can like give you a better estimate, assuming those things don't frequently change size while they're not visible. But I don't know if I'll ever get around to doing that. And apparently native Android does kind of the same thing. So Anthony, as far as the process of going from extras to core, there is no formal process. Extras, I try to keep compatible with core so that anything could pretty much be pulled in at any time, but we haven't felt the need to define a formal process. I think we're going to play that by ear, but the fact that it's all licensed the same way means that there's really no obstacle to Elias or anyone grabbing stuff out of extras and moving them whenever they want. All right, well, we can call that the end of the Q&A for extras. So now I wanted to open up the floor if anyone either has something they would like to show off to everyone here, or has some broader, higher level questions. We'd be happy to have those. Yeah, absolutely, Anthony. Oh yeah, sorry. I have made you a presenter now. So there is now a new button in the bottom tray. And Larry will do you next.
Hi, everybody. I posted this to Slack, but I do want to show it to you and ask some questions as well. It's a thing that just shows the elections, and I've got data going back to 1920. And one of the things that I'd like to be able to do is to be able to flip through these in an animation.
Hey, Anthony.
Yeah.
I'm getting a black rectangle from you. I assume that is not the expectation?
That is not the expectation. Okay, let's see. Is that better? Hang on. Go back. Let me stop sharing.
Yeah, we're only getting your cursor there. If you're...
Okay. Hang on, let's try it again.
I don't know what your OS is.
Yeah.
This feels like a Wayland X Wayland kind of thing, but...
yeah, that's probably it.
Okay.
Why don't we flip over and to the other, to Larry.
All right, yeah. So Larry, why don't you take over?
Okay, go ahead.
I will give you power. Larry, you're a presenter now.
Okay, hold on.
I can fill this gap by saying that Elias and I are planning to split the examples package out of the core repository into a new one called GeoExamples. It'll have the same stuff and more. We're going to move all of the example apps that I just showed into that. And hopefully add some new cool stuff there as well that integrates more of the ecosystem together. I'm not sure when that will be done, maybe in like the next week, but that's something that's coming up. And if you have questions about that, put them in chat.
Can you see my screen then?
Yes, I guess we might not be visible. We thumbs up.
Oh, okay. Yeah, I had hidden you. So I'm working on code to do selections in the editor. This is obviously the kitchen, and you can select stuff with the mouse, and it'll scroll, and you can like select a paragraph, and it'll scroll, and you can, if you click somewhere else, then it'll reset the selection, which maybe is good, maybe is bad. I haven't decided yet. And right now I have a hack just right in the selection code where if you select something, then it prints out here. So select code, print the selection. I've also implemented a selection event, but I haven't integrated that into Kitchen in any other way or my own code anywhere. This is all currently on a branch, which I updated from master yesterday. So I guess that's it. Obviously, I'll be submitting that to submitting that for inclusion when I'm done. But it's been fun. To do this, one of the things the editor does is it's got what it called a line iterator, which dealt with complete lines, and I had to split that up so that it kept a lot more context. And like, it'll give you, if the line is not selected, it'll give you the whole line. If the line part of it is selected, it'll give you the first bit of the line, and then the next bit, and with the selected flag set, and then the next line is the whole line, and then the last line has the first bit that's selected, and then the second bit. So that was an interesting bit of saving a lot more stuff that the editor was already calculating but not saving before. Sorry, Chris, I think you had a question.
Yeah, I was going to ask, what are the things left for you to do before this is ready?
Well, currently this is strictly with the mouse. Like you can't like shift select or anything like that. Right now I'm holding down my shift button, or the shift key, and moving the mouse around, or moving the cursor around, and that's not working. So selecting with the keyword, would be good. I haven't really done any kind of testing with things that are flush right or centered, so there could be errors there. I've done only the minimal testing for a one-line editor, so there could be problems there. I'd also like to integrate with the clipboard. So like if you select something and press paste, then it should paste whatever you're pasting in place of your selection. And if you select something and press copy, then it should copy your selection. So that seems like it would about do it, for a start.
Yeah, that sounds awesome. And with Lucas's work on adding copy and paste directly into the editor, I assume that once this is baked, it shouldn't be very hard to tie those together.
I wouldn't think so. I agree.
I agree with Elias. This is a big step up.
Yeah.
Already.
Yeah. Something actually, it occurs to me that I would like to do. I'm hoping I'll be able to somehow extract the selection code so that other people can use it, because you can lay out text in other places than editors. So it'd be nice if somehow this code were generalizable. I don't know how likely that is, but at very least having it would make it more obvious. It would give somebody else something to build on if they need to do their own text selection in some other kind of widget.
Yeah, I want a selectable label, but that's going to require state that persists across frames. So we'll need to build something slightly new for that.
Yep.
All right. Or a read-only editor. That would work too. I'm going to give Anthony presenter. Let's try that again. Also, Elias, there was a question about adding new APIs, but we can circle back to that. I just wanted to call it out. All right, Anthony, we can see. We cannot hear you yet.
How's that? Is that better?
That's good. Perfect.
Perfect. Okay, so I wrote this little program called Elections, because that's what's happening, at least here in the US, to visualize a couple of things. So in America, you're either a blue state or a red state, depending on your party. And these circles here show the proportion of the population, which is important for how the election results happen. So I have this to show very quickly. Puts it in a grid that sort of shows the geographical layout. One of the things, and it just takes a data file. In this case, we can see what's happening, let's say in 1920. 100 years ago, looked a little different. Population distribution was different and so forth. One of the things that I'd like to be able to do is to slide through each of the years. I haven't been able to figure that out yet. So if anybody's got any ideas, I'll show you the code real quick. Is that it? This is just stuff to read the data. And I read them in their own sort of vectors. Okay. Here's the relevant geo part. So it'd be nice to be able to just loop through these and then have a slider or something to be able to loop through them. That's it.
I think the tabs example would be super relevant as a way of approaching that. Alternatively, there's a slider widget that you could attach the date range to and respond to events in that.
Just one more thing to show. There's a couple of the layouts are configurable. So there's a couple of ways to show this grid. There's the New York Times one. The one that I showed was from a site called 538. You can position things as well. That's the New York Times one. Okay. So the tabs thing is what you would recommend?
I mean, you would need a tab for every year you had results for, so you would need to like be able to scroll through them, which is a thing we can do. I don't know whether I think a slider or a tab would be easier, but they both seem worth exploring.
Or even I was even thinking, a key, forward, backward key.
Yeah,
yeah.
That'd be super easy. You could just have a slice of functions that do the render logic for a particular data set, and then each time press the key.
Yeah, I have those already.
Okay.
So there's a forward and a backward function. It just grabs it from the slice. So there's a slice of these things, and then the process function just renders it.
Well, as always, it's super cool to see the ways that you're doing data visualization.
Thanks.
Keep it up.
Okay. Awesome. Thanks, everybody.
Did anyone else have thoughts or questions for Anthony, or is there anything someone else wanted to show off?
Hi, hello, can you hear?
Yes, we can hear you.
Hi, hello. I'm calling from China, from Shanghai, and I'm working as a embedded system engineer. So I'm quite a beginner for the graphic system. So I have a very general question. I was thinking, what's the relationship between the 2D graphic, the 2D GUI libraries, like the GL library, the 2D GUI library, and the 3D engine, 3D, for example, 3D game engine, such as Unity 3D and Unreal Engine. For example, if I want to do 3D demo program in my embedded system, for example, something like Animotion or SolidWorks for the machine tools, for example, I should I should combine both the 2D GUI library and the 3D graphic engine, or I should just only choose the 3D engine and make the whole window using the 3D engine, and maybe put some 2D widgets on it. I do not need the 2D GUI library at all. I just need a 3D engine. So I was thinking on this very general question.
I honestly don't know. This is my first GUI work is work with Geo, so I'm super unqualified to answer that.
Yes, because when you see something like SolidWorks or these so it has menus and it has some buttons. It looks like a 2D widgets on the bottom or on the top of a window. Then in the center it has the 3D stuff to show the 3D stuff. But I'm not sure if I should use the 2D libraries to draw the window first. Then I use the 3D engine to render a 3D object in the center. Or I just should use the 3D engine to plot the whole window and take over the whole window and find some method to make buttons inside the 3D graphics. So I'm not sure about this topic. Yeah.
I think it's difficult to answer in general what you should do, because it's something you do. It depends very much on your use case. For games, you have one particular answer that may not work for your case, which is, it seems like it's mechanical CAD engineering stuff where you want to display perhaps some very detailed models and so on. But what you can do with Geo is that you can embed the Geo graphics in a program where you have other things drawing. But if you want to do that, I would ask first, why did you choose? Is Go a language that you have to use? Because if it's not, I think there's a C++ library that is very commonly used for game engines. At least all the debugging user interface they use for level editors and for adjusting all kinds of parameters while displaying an in-game view, in-game 3D view. It's called Inkeliz, which is Dear Inkeliz, I think. It's very much an inspiration for this library, this TU library. But since Dear the one advantage that Dear Inkeliz has that TU doesn't is that it's written in C++ and it's very much designed to be embedded and used along with Unity and all other things that you can, all these engines that are typically used are written in C or C++.
Oh, I think there are two reasons. The one thing is I'm a big fan of the Go language. The second thing is I found if I use the 3D engine to take over the whole window and find some method to add buttons and these widgets inside this 3D window, what they offer is usually looks not very nice. When you see the buttons and these widgets offered by these 3D engines, it looks a little bit weird, not as beautiful as these professional GUI libraries. So that's why I want to combine them together. I want to plot beautiful widgets and around the window, and in the center, I just embedded a 3D object in the center of the window. So that's my that's my first thinking. But I'm not sure about this. So.
There's an example called GLFW in the GU repository, which tries to demonstrate what you could do, which is have a context. You have one window, of course, but you can have multiple layers with 3D graphics inside that window. So you can have the entire window taken up by the 3D engine, and it renders whatever it wants inside that layer. And on top of that, you can have it at a transparent layer where all the geographics is displayed. And that's what you could use that GLFW example that is linked to in the chat, because then you have a very not a complete and probably not perfect separation, but you have a high level of separation between whatever the 3D engine wants to do with its graphics context and the things that GU wants to do with its context. And of course, the reason that this is not something that is easy to do is because even though you're using the GPU for both things, both 3D and 2D, the way of rendering these things are very much dissimilar. So that I think that's the most realistic thing that you can do if you're not content with whatever the 3D engine is offering you in terms of 2D widgets. I think layering, sort of putting an invisible layer on top, containing all the widgets and taking all the mouse input and keyboard input would be. I haven't tried it myself, integrating with a large 3D engine, but I think it's a viable path, at least, worth exploring.
Oh, okay. Yes, this is a good idea, and I've thought in this way. Okay. Thank you. So that's my question. Thank you.
All right. I think I'm gonna stop the recording. We've hit an hour.
Just 1 second. I just wanted to answer the question from the chat.
Oh, sorry.
New APIs. So the question was, there's an option that if you implement an option or a feature that depends on native features, then you only implement it for one platform or several, but not all of them. What should you do? I think that's okay. I think we've done that in the past. I just want the more platforms that you can include, the more certainty there is that the API, that the abstracted API available in TU is the right one. But at the very minimum, there should be a comment saying which platforms that work and which don't. And of course, if you use the API on platforms that do not support this feature, it should do nothing or do the obvious thing without the feature. So in other words, there's no blocking of new features just because it's not implemented everywhere. It would be nice if you did, but there are many platforms supported in TU, so I can totally understand if you don't do that.
That's a design philosophy that I've really appreciated throughout QU, is that if it's not supported, do nothing. And I've been trying to replicate that in extras like haptic. You can call the haptic code from Windows, it just does nothing. All right, well, I am gonna stop the recording now. Thanks everybody for coming.